Here we'll do an example of a radical equation. A radical equation is any equation that contains a square root. To begin solving a radical equation, we will leave the square root on the left side and move everything else to the right. The square root x plus 2 will stay where it is. However, the minus x that's on the left, we will move to the right, and when we move it, it will become a positive x. Therefore, we will now have square root of x plus 2 equals x plus 2. Now that we are here, to remove the square root, we will take a second power on both sides, to where we'll raise the left to the second power and raise the right to the second power. The reason we do this is because the second power will cancel out the square root. Once we've canceled out the square root, we can solve the equation normally. Let's raise the left side to the second power and the right side to the second power. If we have this root raised to the second power, this will cancel out and leave us just x plus 2. On the right, we'll have x plus 2 times itself. Notice, when you square a binomial, that means you have to write it twice. It's not enough to just take the x squared and the 2 squared. Therefore, to simplify this x plus 2 times x plus 2, we will have to use the FOIL method to multiply them together. We will take x times x and x times 2. This will give us x squared plus 2x. Then we will take 2 in the front times x and 2 times 2. This will give us plus another 2x plus 2 times 2, which is 4. Then we can simplify by combining the like terms, 2x and 2x. When we do so, we will have x squared plus 4x plus 4 on the right. And on the left, we will have x plus 2. You may notice now we have a second power equation, which we can solve now. For a second power equation, we will take all of the terms and move them to the same side. Since the x squared is already on the right, let's move everything to the right this time. Therefore, we'll take the x plus 2 and move it over. When we move it over, the x will change to negative x, and the 2 will change to negative 2. Therefore, we'll have a 0 on the left side, and on the right we'll have x squared. We'll take 4x minus x and get positive 3x, and then 4 minus 2 and get positive 2. Then we can try to factor this x squared plus 3x plus 2. Let's think of numbers that can multiply to make 2. The only numbers I can think of are 2 times 1. If we add those together, that will give us 3, and that's an automatic match. So we'll now have 0 equals 2 parentheses, and the numbers we'll use are positive 2 and positive 1. We'll write the x's in front, and now that we have this equation factored, we can now split it into pieces and solve each piece. We will have x plus 2 equals 0 and x plus 1 equals 0. For our first equation, we'll take our positive 2, move it to the right, and when we move it, it will become negative 2. So we'll have x equals negative 2 for our first solution. We will also take the positive 1, move it over to the right, and when we move it, it will become negative 1. Therefore, we will have x equals negative 1 as our other solution. In a radical equation, it is critical to test your solutions back into the original equation and make sure that they work. Radical equations will oftentimes give fake answers. We'll do that on the next page. First, we'll try negative 2. We will place negative 2 everywhere we see x. If we do this, we will have square root of negative 2 plus 2. Then we will subtract negative 2 because we have minus x. And we'll say this equals 2. If we simplify the square root, negative 2 plus 2 gives 0, and square root of 0 is still 0. A negative of a negative 2 will give us positive 2, and we'll say that this equals 2. On the left, we have just 2, and on the right, we have just 2, which means this is a true statement, and therefore x equals negative 2 is a true solution. We will now repeat the process with negative 1. We will have square root of negative 1 plus 2. Then we'll have minus negative 1 equals 2. If we take negative 1 plus 2, we will get 1, and square root of 1 is still 1. Negative of negative 1 gives positive 1. This will equal 2. So this statement says 1 plus 1 equals 2, and that is a true statement. This means that negative 1 is another solution. If you try plugging in a number and it gives you a false statement, that means that solution is not a true solution, and it will not count as an answer to this question. However, we verified x equals negative 2 and x equals negative 1 are both true solutions to this radical equation.